We are doing lesson 8.4 today, and it's about significance of experiments. Here's the warm-up. It's the box and whisker plot shows the test scores in Mrs. Howard's first period math class. Find the minimum, maximum, median, and quartile values for the data. Take a moment, pause the video, then press play to see the answer. So our minimum, which is the smallest value, and that's the very end whisker here, if you would kind of bring it down, we find that the minimum is at approximately 82. The maximum, which is now on the other end, is at approximately 98. The median, or the middle value, if you bring it straight down, is at 90. Q1, or the first quartile, is at 88, and Q3, the third quartile, is at 93. Imagine, suppose you flipped a coin 20 times. Even if the coin were fair, you would not necessarily get exactly 10 heads and 10 tails. But what if you got 15 heads and 5 tails, or 20 heads and no tails? You might start to think that the coin was not fair after all. Hypothesis testing. It's used to determine whether the difference in two groups is likely to be caused by chance. Questions to consider. Is it possible to get 19 heads and 1 tails when flipping a coin 20 times? Well, yes, it is possible. What would you think about a coin that had such outcomes? You might start to think that it's not fair. Now, could you actually conclude that it's unfair? Well, no, not really. I mean, you can inspect the coin, but overall, concluding that it's unfair just based on those 20 flips, it's not enough to say that it's unfair. Now, what can you actually conclude? Well, you can conclude that it's very unlikely, but is possible only by chance. Now we're going to talk about what's called the null hypothesis. The word null means zero, and the word hypothesis means a proposition. One of many definitions for hypothesis, but a proposition. So the null hypothesis states that there is no difference between the two groups being tested. So no difference between the two groups being tested is your null hypothesis. So in example 1, a researcher is testing whether a certain medication for raising glucose levels is more effective at higher doses. In a random trial, fasting glucose levels of 5 patients being treated at a normal dose group A and 5 patients being treated at a high dose group B were recorded. The glucose levels in I don't know exactly what that unit is per liter, are shown below. State the null hypothesis. Well, the null hypothesis is a statement explaining that there's no difference between the two groups. So here, our null hypothesis would be there's no difference in the glucose levels of group A and B. Now, even if maybe the data shows something else, but that's not the question was asking. The question just says, state the null hypothesis. We don't know whether or not it's true or false, but just what would it be? Example 1 continued. Now, does the researcher have enough evidence to reject the null hypothesis? So for this, we are going to create a box and whiskers plot. For group A, my box and whiskers plot will be in purple. For group B, my box and whiskers plot will be in blue. I want you to take a moment and begin working on the box and whiskers plot on your own, so pause the video. So I have my box and whisker plots made. Remember, the median's the middle value, but you must order things from least to greatest. Q1 is the median of everything to the left of the median, and Q3 is the middle of everything to the right of the median. So now, does this researcher have enough evidence to reject the null hypothesis? Remember, null hypothesis stating that there's no difference between the glucose levels of groups A and B. Well, our medians, our middle values, are quite different, and we actually have a higher maximum. So maybe they're not significantly different, okay, but they are different enough. So you could probably say that, yes, we have enough evidence to reject the null hypothesis because there is clearly some sort of a difference here. The magical number, a z-score, helps determine how much a study varies from the claim. It is calculated by z equals x bar, which is the original average, minus mu, which is the claimed average or claimed mean, so x bar minus mu divided by sigma, which sigma is your standard deviation, divided by the square root of n, and n is your sample. A z-score that is larger than 1.96. So when you have a z-score larger than 1.96, we can reject the null hypothesis. We can only use this formula, though, if n, our sample, is greater than 30, which anytime we're talking about this in class or in my class, it will be greater than 30. So example 2, an SAT test prep company claims that its private tutoring can boost scores to an average of 2,000. In a random sample of 49 students who were privately tutored, the average was 1910, with a standard deviation of 150. Is there enough evidence to reject the claim? So calculating the z-score. Here we have x bar, which is the original mean, is equal to 1910. Mu, the expected average, is 2,000. Sigma, standard deviation, is 150. And n, the sample, is 49 students. Calculating z-score, we have z equals, it's x bar, which is 1910, minus mu, which is 2,000, divided by sigma, which is 150, divided by the square root of n, which is 49. That then equals, we get negative 90 divided by 150 over square root of 49 is 7. When dividing a number by a fraction, it's really multiplying by its reciprocal, so we really have negative 90 times 7 over 150. That ends up getting us negative 630 when you do 90 times 7 over 150, and that fraction reduces to negative 21 over 4, which we can say then our z-score is approximately negative 4.2. Now, something on the last slide that I guess I forgot to mention is when we're going to be talking about z-score, we'll always be talking about it in terms of plus or minus, just because think about with standard deviation, and when we were referring to when we would find outliers, identifying outliers, we would add and subtract 3 standard deviations from the mean. Okay, this is kind of a very similar concept with z-score. Your z-score will always be plus or minus of whatever the mean is. And when we're using the z-score to determine if we can reject a null hypothesis or reject a claim, we always take the absolute value of the z. So the absolute value of our z-score here would be 4.2. that is a value that is greater than 1.96, which means, yes, there is enough evidence to reject the claim. So just remembering with z-score, we'll always be talking about it in terms of plus or minus, but when determining if we are going to reject a claim, we will always use the absolute value version of whatever the z-score is. And that concludes our lesson. I know that if you have paper notes, it probably says that there's some sort of an assignment slide. You can ignore that last slide. This is the end of our notes.